Welcome to Lesson 2.2, Nature of Matter. Again, as we go through this lesson, make sure to fill in your notes and write down your vocabulary. So as we continue in our introduction to basic chemistry, we see the basic unit of matter, the atom. Derived from the Greek word atomos, which means unable to be cut, atoms are very small. Placed side by side, 100 million atoms would make a row only about 1 centimeter long. Atoms are composed of three subatomic particles: protons, which are positively charged and found in the nucleus; neutrons, which have no charge and are found in the nucleus; and electrons, which are negatively charged and found outside the nucleus. Electrons are in constant motion in the space surrounding the nucleus, and they are attracted to the positively charged nucleus, but they remain outside because of the energy of their motion. Because atoms have equal numbers of electrons and protons, their positive and negative charges balance out, and atoms themselves are electrically neutral. The diagram here on the right shows a carbon atom, and if you count, there are 6 protons in the nucleus and 6 electrons outside the nucleus. And if you go to Blend, you can see a link to an interactive periodic table where you can see the atomic number, or you can see the tile for the carbon atom there, and you can see how many protons are in the nucleus. So, as mentioned on the last slide, the number of protons in the nucleus determines which element an atom is, while the number of electrons surrounding the nucleus determines which kind of reactions the atom will undergo. The atomic number is the number of protons in the atom. Unlike the number of protons, the number of neutrons for any given element can vary. The mass number is just the total number of protons and neutrons in the nucleus of an atom. So the mass number just equals protons plus neutrons. The relative atomic mass, or atomic weight, is the weighted average of all masses of an element's isotopes. And we're going to talk about isotopes in just a moment. So continuing with atomic structure, the number of electrons in the outermost shell of a particular atom determines its reactivity, or tendency to form chemical bonds with other atoms. The outermost shell is known as the valence shell, and the electrons found in it are called valence electrons. In general, atoms are most stable, or least reactive, when their outermost electron shell is full. Most of the elements important in biology need 8 electrons in their outermost shell in order to be stable, and this rule of thumb is known as the octet rule. Now looking here at the periodic table, elements are placed in order on the periodic table based on their atomic number, or how many protons they have. In a neutral atom, the number of electrons will equal the number of protons, so we can easily determine electron number from atomic number. In addition, the position of an element in the periodic table in its column or group and row or family provides useful information about how those electrons are arranged. Group 1 here, again, if you look at the columns, those are the group numbers. Group 1 has 1 valence electron. Group 2 has 2. The transition metals are a little bit different in terms of their valence electrons, but you'll go more into depth on that in chemistry. Group 14 have 4 valence electrons. 15 have 5, 16 have 6, 17 have 7, and then 18 is full, okay, which makes sense because the noble gases are inert or non-reactive. You'll learn about different electron models along with shells and orbitals more so next year. So for now, the most important thing is to understand that valence electrons are what help determine what type of bond that specific element wants to form and how reactive that element is. So an element is a pure substance that consists entirely of one type of atom. Elements are represented by 1 or 2 letter symbols as seen on the periodic table, and the elements are organized by atomic number. There are more than 100 elements, but 6 elements make up 98% of the human body. We have carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Now there are other elements that make up humans, but we call those trace elements. Atoms of an element may have different number of neutrons. As seen in the table below, although all atoms of carbon have 6 protons, some have 6 neutrons, some have 7 neutrons, and some have 8 neutrons. An isotope are atoms of the same element that differ in the number of neutrons they contain, but they do have the same number of protons. Isotopes are identified by their mass number. So for example here, carbon 12, carbon 13, carbon 14, those numbers after are the mass numbers. Remember, the atomic mass is different from the relative atomic mass or atomic weight, which is the weighted average of all masses of an element's isotopes. So what atomic weight does carbon have? So if you want to go to Blend and look at that periodic table really quick, you can look up what atomic weight carbon has. So if you went and looked it up, carbon has an approximate atomic weight of 12.011. So what that tells us is the most abundant isotope of carbon is carbon 12. And again, because they all have the same number of electrons, all isotopes of an element will have these same chemical properties. So there are radioactive isotopes, meaning that their nuclei are unstable and break down at a constant rate over time. The radiation these isotopes give off can be dangerous, but radioactive isotopes also have a number of important scientific and practical uses. Geologists can determine the ages of rocks and fossils by analyzing the isotopes found in them. Some isotopes can be used as labels or tracers to follow the movement of substances within organisms. And I put a really cool optional article here. If you want to check out more on that, you can click on that link in Blend. So now we're going to move on and talk about elements and chemical bonding. Atoms can join with other elements to form stable substances, and in nature, most elements are found combined with other elements and compounds. The force that joins those atoms is a chemical bond. A compound is a substance formed by the chemical combination of two or more elements in definite proportions. Compounds are represented by chemical formulas, and a couple examples are H2O, water, NaCl, sodium chloride, or table salt. Those are examples of chemical formulas. The physical and chemical properties of a compound are usually very different from those than the elements from which it was formed. So for example, hydrogen and oxygen, both of which are gases at room temp, can combine explosively and form liquid water. Now this next part, a molecule, is the smallest unit of covalent compounds, and the term molecule is used to describe any atoms that are connected by chemical bonds. Every combination of atoms are molecules. A compound is a molecule made of atoms from different elements. All compounds are molecules, but not all molecules are compounds. So for example, water is both a compound and a molecule. CO2 or carbon dioxide is a compound and a molecule, but O2 gas is only a molecule just because it's made up of one element. So, compounds are held together by chemical bonds. The number of electrons in the outermost shell of a particular atom determines its reactivity or tendency to form chemical bonds with other atoms. There are two main types of chemical bonds. Those are ionic and covalent. Ionic bonds are chemical bonds formed when one or more electrons are transferred from one atom to another. An ion is an atom that either gains electrons or loses electrons. So it is either positively or negatively charged. So pause and think to yourself. If an atom gains electrons, what charge does it have? And then think to yourself as well. If an atom loses electrons, what charge does it have? So, if an atom gains electrons, it gains negativity, therefore it becomes negative. If an atom loses electrons, it loses negativity, therefore it becomes positive. Covalent bonds are chemical bonds formed when the electrons are shared between atoms. So down here are a couple photos. Okay, so right here, the transfer of an electron, this would be an ionic bond. Okay, whereas water, as we talked about last class, is sharing. Therefore, that is covalent. So here's another quick recap from last class. So recall intermolecular versus intramolecular forces. Remember, intra are the forces that hold atoms together within a molecule. Inter were forces that exist between molecules. And water is a polar molecule, or its intramolecular bonds are polar. Now, next is the portion you don't necessarily have to understand or memorize. It'll be good to know as we talk about bonding, but the next few slides have some details that aren't on your notes and you don't have to worry about right now. So while the intramolecular forces keep the atoms in a molecule together and are typically the basis for the chemical properties, the intermolecular forces are those that keep the molecules themselves together and are typically responsible for all the physical properties of a material. So the main types of intramolecular bonds are ionic bonds, covalent bonds, and metallic. Now we've just saw these two, and again, ionic bonds are formed by the complete transfer. Covalent bonds are formed between atoms that have similar electronegativities, which is the affinity or desire for one particular atom to hold on and keep an electron. Within covalent bonding, there are two types, nonpolar covalent and polar covalent. So again, as we continue, this is some extra information that you don't need to memorize or worry about, but it is useful in case you're interested. So there are main types of intermolecular bonds as well. And if you remember, intermolecular forces are much weaker than the intramolecular forces of attraction, but they are important in determining the physical properties of molecules like their boiling point, melting point, density, and enthalpies of fusion and vaporization. So the few types that we have, dipole-dipole, hydrogen bonding, and London dispersion. So we already talked about hydrogen bonding last class, but just to revisit, that is whenever you have a partially positive end of hydrogen and it's attracted to the partially negative end of an oxygen, nitrogen, or fluorine of another molecule. H-bonds are a relatively strong force of attraction between molecules, and considerable energy is required to break those bonds. So how do bonds affect the properties of compounds? The general rule of thumb is that the stronger the intermolecular forces of attraction, the more energy is required to break those forces. That translates into ionic and polar covalent compounds generally having higher boiling and melting points, higher enthalpies of fusion, and higher enthalpy of vaporization than covalent compounds. So again, those last few slides are just some details of bonding on extra information. You don't need to worry about memorizing this. Just understand the main two types of bonds for this course are ionic and covalent. So we have reached the exit ticket. Go ahead, pause here, and try to answer these on your own. Okay, so let's go ahead and go through this. So protons and neutrons are both found in the nucleus. Remember, protons are positively charged. Electrons are found outside of the nucleus, and they are negatively charged. The atomic number is the number of protons in the atom, and the periodic table is arranged by the atomic number. The number of electrons, number 3, in the outermost shell, or valence electrons, of a particular atom determine its reactivity or tendency to form chemical bonds with other atoms. What elements make up 98% of life? That was carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Number 5, how is the relative atomic mass or atomic weight determined? The atomic weight is the weighted average of all masses of an element's isotopes. Number 6, an element was a pure substance that consists entirely of one type of atom. A compound is a substance formed by the chemical combination of two or more elements in definite proportions. And then elements make up compounds. Number 7, we have ionic and covalent bonds. And remember, an ionic bond is a chemical bond formed when one or more electrons are transferred from one atom to another. A covalent bond is a chemical bond formed when the electrons are shared between atoms. So that was the end of lesson 2.2. Again, check your notes and vocabulary, reach out with any questions, and thank you for watching.